Very good evening, all of you. Hope you all are doing well. Let's start with today's session. Quick recap of yesterday's session. I guess in yesterday's session, we discussed about bitwise operators, then compound assignment, compound bitwise assignment operator, and then we started with shift operator. Just today, we will take that shift operator little bit again because some recording was not done yesterday. Some part got corrupted. So what I'll do is that slide reading and all was not recorded in the yesterday's session. That will do it quickly again. Just to quickly revise, we started with shift operator, that is two greater than, right shift. Okay. Then three greater than also is there, and two less than. This is left shift, and these are two right shift, but the first one is called as sign fill right shift, and this is called as zero fill right shift. They are binary operators. First of all, remember they are binary operator, and they work only on integral data type. Integral means int and long, no float, no double, char. Char and all, they are going to get promoted. They'll work on char, but promoted to int. Byte promoted to int. Short promoted to int. So minimum integer or long, and they are binary operator. A right shift end time, A right shift end time, or A left shift end time. Okay. And what we had discussed yesterday, it takes the bit representation of this first operand, that is A. Bit representation means memory representation. I hope you know it. Whatever the value is, its equivalent memory representation. Memory representation means binary, means bit representation. So it takes the bit representation of A and shifts the bits right side n times or left side n times. Either it will shift it to the left side n time or right side n time. N is called as the shift distance. Okay. And A will be promoted. Either it will be promoted to int or long. And the bits are shifted right side or left side n time. Okay. Now, what is the speciality of 2 greater and 3 greater? That too I have to tell you. And I've told you yesterday, just I'm quickly revising. So this 2 greater, what it does is, it is sign fill right shift. Means whatever your bit pattern is, suppose your bit pattern is 1, 0, 1, 1, 0, 1, 0, 1, whatever. So it is shifting right. So this LSB will go out, here 0 will come, here 1, here 0, here 1, then 1, then 0, and then 1. All are shifted one bit. Now the question is, what will come at this new MSB? This is the new MSB, most significant bit. So what is going to come at this MSB? So when you're using 2 greater, the old sign bit is dropped. If your old sign bit is 1, 1 will be preserved. Old sign bit is 0, 0 will be preserved. Therefore, this is called as sign fill right shift. Okay, so I hope you're understanding. 1 goes out, then 1th bit will come to 0th bit, 2 bit at 1 bit. But what will come in MSB? Old sign bit. So if your old sign bit is 1, 1 is dropped. Old sign bit is 0, 0 is dropped. Therefore, this is called as sign fill right shift. But when you're using 3 greater, guys, if you remember yesterday's session properly, 3 greater whenever we use, irrespective what the old sign bit is, always in MSB 0 will come. If you agree with me, yesterday, if you have attended the session properly, it will do the normal shifting. Okay. 0th bit will go out, 1th will come in 0, 2 at 1, and second last, last at second last. But what will come in MSB? Always 0. Therefore, this is called as zero fill right shift. Okay. And this is left shift. Okay. So in case of left shift, suppose I'm shifting this to left side. So this one will go out. Here zero is going to come. Here one, here one, here zero, then again one, then zero, then one. Now the question is what will come at LSB? That is least significant. So always zero. Here there is no question of old bit or anything. Getting? So always what will come inside? Zero only. Okay. So always zero is coming in LSB. Okay. So both are clear. If you have kept by mistake your mic unmute, please mute it. And if you want to ask something, please ask it. Someone has kept mic mute, I guess. Yes, yes, yes,
Excuse me, sir.
yes.
Bhaktananda here, just now joined. So, can you explain one more time that shifting means left shifting?
Actually, you'll get it in the recording also. Like
Okay.
you joined late. All the recordings are there. Yesterday's recording, if you see, no, it will be there, the last part.
How to get those means earlier session record, previous records?
I'll give you, don't worry.
Okay.
I'll share you. From the lecture one, I'll give you everything.
Okay.
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 Okay. So the basic idea you got it that first operand is shifted right side or left side n time. N is called as a shift distance. Okay. Generally, when you shift right side, the value is halved. It become half. And whenever you shift left side, it is becoming double. Okay. So any binary value. Now, suppose if you are having this as 5 in binary. Okay. And you're shifting it left side, right? So this 1 will come here, this 0 will come here, 1 will come here, and 0 is coming inside. So you can check the old value is doubled. The old value, this is 4 and this is 1. So 4 plus 1 is 5. Now this has become, actually this is 2 and this is 8, right? Or no, 2 power, 2 raised to 0, 2 raised to 1, 2 raised to 2, 2 raised to 3. So when you shift it, now 1 is coming at 2 place and 8 place, right? Right? Eighth position, whatever is there. Eighth position means 2 raised to 3. Third position, which is 2 raised to 3, 8. So 8 plus 2 is 10. So you can see when 5 is shifted, it becomes 10. It is doubled. And same way, when you shift it towards the right side, it will become half. Okay. It is floor half, not float half. Okay. Like 0, 1, 0, 1. If this is 5, you're shifting right side. So 1 will go out, here 0 will come, here 1, here 0, and this old 0 is going to remain as it is. Now this has become 2. So 2 is half of 5. We are not taking floating half, huh, guys. Half of 5 is actually 2.5, but what is the floor of 2.5? 2. Okay, nearest integer. So what is the nearest integer less than equal to 2? 2. Less than equal to 2.5? 2. Now, one more point I had told you that is about the shift distance. I hope you remember that rule that if your first operand is promoted to integer, then the shift distance is calculated like this. Whatever is your n is masked means ending with 1f. Now, actually, 1f is 31. F in hexadecimal, F is in hexadecimal, which is 411111. Okay, and this is 1. So in binary, there are 5 ones. 5 ones is making decimal 31. Yes or no? This is 1, 2, 4, 8, and 16. If you add them, it is 31. So what you have to do, the second operand is to be ANDed with 1F, and whatever you get, that is your shift distance. And same way, if your first operand is promoted to long, that time you have to mask it with 3F. Okay. And what is 3F? 63. 3F. F means 4 ones and 3 is 1 1. So this becomes 63 if you take the total of it, like 1, 2, 4, 8, 16, and 32. If you add them, it becomes 63. So you have to mask it with 63, and whatever result you get, that is your actual shift distance. Okay. So generally, if your n is less than 32, no need to find out shift distance. Or if it is less than 64, no need to find out shift distance. It is going to remain same. Now, quickly we will go through these points. Yesterday we have done this work, but the last part of the recording little bit got corrupted. Therefore, I'm reading it again. Okay. So what this shift operators do? So the binary shift operators form a new value by shifting the first operand, okay, either left side or right side, second operand times. Okay. So it is going to shift the bits left side or right side the second operand time, and that is called number of times. And it will work only on integers. Remember, that is the rule. These operators work only on integers. And how many times you have to shift? That is in the second operand. And what is to be shifted is in the first operand. So the number of shifts, also called the shift distance, is given in the right hand operand, and what is to be shifted is given in the left hand operand. Okay, I hope you're clear with it. And here promotions are applied, but only the first one is promoted, and therefore we call it as unary promotion. The first one is either promoted to int or the first one is either promoted to integer. Sorry, long. Int or long. Only two promotions are allowed. And how do we calculate shift distance? That I told you. The right hand operand, whatever the right hand operand is, it is ANDed. ANDing is only called as masking. So it is ANDed with 1F if your first operand is promoted to integer, and it is ANDed with 3F if the first operand is promoted to long. Getting? Very simple rule it is. A, and you're shifting right side, left side, doesn't matter. So if your A is promoted to integer, then n is masked with 1F, and after masking, whatever you get, that is your shift distance. And if A is promoted to long, then this is masked with 3F, and after 3F, whatever masked result is, that is your shift distance. Okay. Then all these operators yesterday I told you. This also we have done in the yesterday's session. Only slide reading part didn't get recorded. A shifted left side n times. We are shifting A to the left side n times. So always remember, when you shift left side, what will come in the LSB? 0. It is going to shift all the bits towards left side. Just now I told you, like if your A is 1 0 1 0, suppose 1 1 0 0, something like that. This is your A, and one time suppose I'm shifting. So this 1 will go out. Here 0 will come. Here 1, here 0. Okay, here 1, here 1, here 0, here 0. And what is going to come inside? Always 0. It doesn't matter what is here. The old sign, old bit is not concerned over here because this side is not having any significance. So what will come always inside? 0. Okay. And if you are shifting towards the right side, then always remember, if this 0 go out, here 0 is coming. Here 1, here 1, here 0. Getting? Then this 1, then here 0 will come. Here 1 will come. And what will come over here? So if you are using 3 greater, always 0 will come. And if you are using 2 greater, the old sign bit is preserved. If your old sign bit is 1, 1 is preserved. Old sign bit is 0, 0 is preserved. Okay? So remember, and this is one common interview question, that when the result of 2 greater and 3 greater comes same. Very common sense answer. When you'll get the result of shifting right side by 2 greater and 3 greater same. Can anyone answer? If you're shifting it right side using 3 greater or shifting right side by using 2 greater, when you will get the answer same.
The sign bit will be zero, the first bit.
Uh, Okay, when the sign bit is 0. But when the sign bit is 0, when the number is positive. I hope you know it. No?
Yes.
In Java, negative numbers are represented in 2's complement. And always remember, negative number, the sign bit is always 1. Getting? So always remember, as you said, when the sign bit is 0, then both will give the same result. But if the sign bit is 1, then 3 greater result is different and 2 greater result is different. Means in short, when the number is positive, irrespective you are using 2 or 3, the answer is going to be same. Okay, so remember that. Okay, and always remember A is the integer value which is promoted to int or long, whose bits you want to shift, and n is the number of times which you want to shift the bits. Correct? Given that A contains the value whose bits are to be shifted, and n contains the number of bits to shift. Okay, so how many times you want to shift is this thing. And yesterday I told you when you shift left side, it is doubling the value. And when you shift right side, it is going to half the value. Okay, and generally these shift operators are used in encryption, decryption, and all. Okay, generally in security related programs, if you want to do, then there these shift operators are very much useful. Okay, some examples we'll go through. Quickly, we will see the examples. See here. The first example, I is 12. I is 12. And you're shifting I to the left side 4 times. And yesterday only I told you, when you shift left side, the value is going to double. Now here it is going to double 4 times. One time you shift, it is double. So same with 4 times, double, it's double, and again it's double. So see, 12's double is 24, isn't it? 12, if we double it, it becomes 24, one time. One more time, 48. One more time, 96. And one more time, 192. Getting? 4 times it is going to double. And you can cross verify that answer. See, for that reason, this bit representation is shown. First of all, do you agree that 1100 is the binary of 12? Others also should respond, guys. Others are there or no? Or only Shamli takes the responsibility of answering. 0011. Is this right? Binary 12. Decimal 12. See here, 12. Is it right? 1, this is 2, this is 4, and this is 8. It is everything in power of 2. 2 raised to 0, 2 raised to 1, 2 raised to 2, and 2 raised to 3. 2 raised to 3 is 8, 2 raised to 2 is 4, 2 raised to 1 is 2, and 2 raised to 0 is 1. 8 and 4 is right, 12. 8 and 4, 12. So that is binary of 12. You're shifting it which side? Left side 4 times. So when 4 times, the 4 zeros will come inside. Is this whole nibble going to come here? 4 bits make one nibble. Right or no? 4 bits make one nibble. So 4 bits are shifted. So 4 zeros come inside. Now you take the decimal of it. Here for time being, I've shown the hexadecimal of it. You can check this whole zero, zero. Hexadecimal means 4 bits, which are nibbles. I'm making it into hexadecimal. So this becomes 0, 0, 0, 0, 0. This is 12. To 12 in hexadecimal is C and 0. Is 12 in hexadecimal C. A is 10 in hexadecimal. B is 12. Sorry, B is 11 and C is 12. Okay. And if you find out the decimal of it, it is 192. See, hex is C0. So in hexadecimal, we write 16 power, 16 raised to 0, 16 raised to 1. Getting? So how many times I'll multiply this 16 with 16 into 12? C is 12. So 16 into 12 is how much? 192. Or you can take the binary decimal only. See here, 0, then that is 1, 2, 4, 8, 16, right? 32, 64, 128. So if you add 64 with 128, is it also 192 only, guys? If I take direct binary, this is 0, means 2 raised to 0, which is 1, 2, 4, 8, 16, 32, 64, 128. So where is 1 at 64 and 128? If you add it, it is going to be 192 only. Okay. So many ways to tell you, right? And 192 is 4 times double of 12. Yes or no? At least tell yes, no.
Yes, sir.
Right? Directly also I can show 12 left shift 4 times. Do you get answer 192? Okay, I already told you J shell is only to test the parts. If you want to write entire code, you have to go for some ID. So we will be going, yet we have not reached to that stage of writing an entire code. Okay, okay. This part is clear. Now coming to the next one. Next is byte B equal to minus 42 and short n is equal to 4. Again, here you are shifting that minus 42 which side? Left side 4 times. B is what? Minus 42. Okay, you are shifting left side how many times? 4 times. Always remember this B is byte. So before doing shifting, it is going to get promoted to integer. It will get promoted to integer. Understanding? No? Okay, but minus 42, how do you represent? Yesterday only I've shown you. Plus 42 is 2's complement. No? Can you tell me plus 42? 0, 1, 2, and 3. Okay, this is one nibble. And then 4, 5, 6, and 7. For time being, I'm taking 1 byte because initially it is byte, right? 42 is how much? 2 raised to 5 is 2 raised to 5 is 32. 2 raised to 3 is 8. And 2 raised to 1 is 2. Is it making 42, guys?
Yes, sir.
Okay, this is positive 42, but we don't want positive 42. We want negative 42. Is it or no? 32 plus 8 is 40. 40 plus 2 is 42. This is positive 42. But we don't want positive 42. We want negative 42. So how is the negative value stored in computer's memory? Others, those who have joined, please tell.
Two supplement.
2's complement, right or no? And what is 2's complement? From LSB
Yes.
till we don't get first one, we keep it as it is. So I'm going to keep this 0 as it is, 0, 1. From LSB till we don't get first one, keep it as it is. And after that, we are going to complement. 1, 0, 1, 0, 1, 1. This is your real minus 42 in computer memory. Yeah? From LSB till we don't get first one, keep it as it is. After that, toggle. 0 becomes 1, 1 becomes 0. This is minus 42. And you can see here, I've shown it on the screen. Is this minus 42, 1101, 0110? Is it same? Yes. But this is in byte. Now, before doing shifting, it is promoted to integer. And when the promotion is done, what is happening? Whatever the sign bit is, guys, is pulled till 31th bit. So what is your sign bit now? 1. So that 1 only is pulled. 1 only is shifted till 31th bit. Understanding? So till 31 bit, what will be there? All ones. So see, this is the promoted value. This is your minus 42 and this is the promoted minus 42 to integer. Is this one pulled till 31th bit? Now you are going to shift it 4 times. Okay. Now we have to shift this how many times? 4 times in the left side. So tell me, is this whole 4, when you shift it, is this whole nibble gone out? This whole 4 gone out. This 4 come here. This 4 is coming here. These 4 ones are coming here. Here, here. This 1101 come here and 0110 come here. And what is coming inside? 4 zeros. Now, if you want to find out the decimal of this, are we supposed to directly convert to decimal, guys? Or are we supposed to first convert to 2's complement? Can anyone answer?
We can use that because it's already.
Check first. Are we supposed to directly convert to decimal? This whole thing, am I supposed to directly convert to decimal or first I have to convert this to 2's complement? Check again. I gave hint also. Yesterday also I have told you, how do you recognize that whether we are supposed to directly convert to decimal or first we have to take 2's complement and then convert to decimal? By checking the sign bit, guys. Yes or no? How do you forget that? What is the sign bit? I'm moving the mouse over there again and again to give you the hint. When I'm moving the mouse, you can see when you watch KBC. KBC, you should watch that program for Mr. Amitabh Bachchan. Getting the way he conducts the program. When any person is about to do wrong, he always hints like, "Are you sure? Are you sure?" And then still, if you want to do wrong, then he says, "Do whatever you want." Getting? He gives you the hints. If you have watched his program, the way he conducts the program is really an amazing person. When the person is about to do wrong, and generally when that person has earned a lot and because of that one mistake he's going to directly come down, that time he gives hints, he starts giving hints. Getting the same way I am also trying to show you here. I'm moving the mouse pointer here, so you should understand that. What is the sign bit, guys? Sign bit is 1.
One.
So when the sign bit is 1, is the number negative for computer? Yes or no? At least tell me that. Is the number negative for computer? Is it taking so much time to decide, to tell yes or no? A very pathetic thing. It should not happen. Tell me the sign bit is what? 1. So when the sign bit is 1, guys, the number is negative. When you get sign bit 0, the number is, check the previous example, 12. So in case of 12, is the sign bit 0? The number is positive. Whenever you get sign bit 1, sure the number is negative. And whenever the sign bit is 1, the number is negative. You cannot take direct decimal. If you go to take direct, it will be a very huge number, guys. Just check. This is 1, this is 2, this is 4, 8, 16, 32, 64. And this way, wherever you get 1, all that you have to add, which will be a very, very huge number. Understanding? Always remember when the sign bit is 1, you're not supposed to take decimal directly. First, you have to convert to 2's complement. Okay, so can anyone tell me the 2's complement of this? From LSB, we'll start writing 0, 0, 0, 0. Getting? Then tell me 0,
One.
then 1.
Then zero.
This is right. After that, 0,
Complement.
1,
One. Zero.
isn't it? Okay, 0, 1,
Zero.
0, 1.
One.
Now 0,
One.
1,
Zero. Zero. Zero.
0. And after that, everything is 0 till 31 bit. Do you agree? Others, at least say yes or no, guys. Others, those who join, please you check patience. Okay? All others are going to become what? Zeros. Shamali,
Six.
others are there or no? Or you alone joined?
No, no. There are.
Then now I'll start making memes for that. Right or no? You're just watching from the window, right? There's a window, may say that that window door, you're small opening that door, and then you're just watching. And if sir asks, again I close the door and I run away. Like that you're doing, I guess. This is clear. So from LSB till you don't get first one, you're keeping it as it is. And after that, you complement 0, 1, 0, 1, 0, 0, 0, 0, 0, 0, 0. Now you have to convert it to decimal. Understanding? But whatever answer you'll get, you have to put sign minus. Understanding or no? You have to put sign minus. Why I have to give whatever answer now I'll get, I have to put sign minus because you have not got the decimal directly from your answer. This was your real answer, but you have not converted this to direct decimal. First, you have to you have converted to 2's complement and then decimal. Whenever 2's complement and then decimal, the sign has to be minus because basically we take 2's complement for negative numbers only. So can anyone tell me how much will be the decimal? 0, 1, 2, 3, 4, 5. This is 32. Now, a smart person will direct read and tell 672 because you only have written. Okay, so 32, 64, 128, then 256 skip, right? And 512,
Well,
right or no?
yes.
Here it is 256 and here it will be 512. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 is 512. 4, 5, 6, 7, 8, 9. Okay? Is it right? Now you add them. 512 plus 128 plus 32. You should be able to add it quickly. Right or no? 500 and 600.
40.
Right? It is 6.
40 plus 40.
This is 600 and this above things you have to add. This is 50, 60 and 12, 72,
Yeah. Sorry.
right? So you get 672. And that is the answer here. Minus 672. Okay. Anyways, other examples we'll see. Okay. Now in this case, you can check. When I'm shifting it, A right side three times. A is shifted right side three times. And you store it in J. You get 256. But the same answer, if I try to store in B, it is going to give error and therefore I have to do casting. Okay, I hope you should know it, why I'm doing casting over there. Okay, before that, just tell me A shifted left side three times. When you shift 32 left side three times, is it going to double three times? 32's double, it's double, and it's double. 32 shifted one time.
Again.
If it is shifted one time, you get 64. One more time shifted, 128. And one more time shifted, 256. It is going to double, no?
Yes.
32's double is 64. 64's double is 128. 128's double is 256. Okay, you can check the answer. See, guys, this is 30. Do you agree? This is 32. 0, 1, 2, 3, 4, 5. So fifth bit is 1. So this is 32 in binary. You're shifting three times. So three zeros will come inside. Three zeros come inside and then the whole thing. Okay? Shifted. We are writing in hex form like 0, 0, 0, 0, 0, 1, 0, 0. Okay. But decimal, if I make, how much it is? At which place you are getting 1? 0, 1, 2, 3, 4, 5, 6, 7, 8. So at 8 place 1. 8 place 1 means 2 raised to 8. 2 raised to 8 is how much? 256. Two powers, you should be able to do it orally. 2 raised to 0 is 1. 2 raised to 1 is 2. 2 raised to 2 is 4. 2 raised to 3 is 8. 2 raised to 4 is 16. 2 raised to 5 is 32. 2 raised to 6 is 64. 2 raised to 7 is 128. And 2 raised to 8 is 256. Okay? Okay, the answer is 256. And if you directly store in J, which is integer, you will get 256. But if you try to store in B without doing this casting, do you think error will come, guys? Can anyone justify? At least one. I don't know why students don't
Sir,
answer.
can you repeat the question, please?
My question is, if I don't do this casting, round bracket byte, this casting, if I don't do, I directly write B is equal to B left shift 3. Sorry, A left shift 3. And I'm not doing that casting. Will the statement give error? Hmm.
No, I
If
don't
anyone
get it.
else has got the answer, you can tell me. Huh?
B is already in byte.
B is already byte.
Yeah.
But what is the answer? This whole answer is in which data type?
It's an int.
Then you know it.
So
It is
you have
int.
to
You
mandatory,
can.
it
uh,
cast is
you
mandatory.
have to cast it. Otherwise, it will give error, incompatible type, possible lossy conversion from integer to byte. And I've been telling you in the past sessions so many times, so many examples also have shown. Yes or no? And in the previous slide, we have discussed that before doing the shifting, this values are promoted. So A is actually byte. It is still here only. But before doing shifting, it is promoted to integer. Getting? So ultimately, your answer is integer. But can you store an integer in a byte in Java? Can you store an integer in a byte? Is there a situation of narrowing?
No.
No? No or yes? Is it a
In Java,
situation of
narrowing is
narrowing?
not possible.
But the situation of narrowing has come. The situation is narrowing. You're trying to store a int in a byte. And in Java, automatic narrowing doesn't happen. And as automatic narrowing doesn't happen, it gives you a error. That possible lossy conversion from int to byte. And to overcome that error, you have done casting. But because of casting, how the information is getting lost, you can see. As you cast it to byte, this is your actual answer. Is it or no, guys? Where I'm moving the mouse pointer, this is your answer. But when it got casted to byte, is it keeping only this byte and above that, whatever is there after it is truncated. So what is remaining? This byte is remaining. So what is the decimal of that byte? Anyone, any dumb person can tell. All the 8 bits are zero. So what is the decimal of that?
Zero.
Zero. And that is the reason here zero come. Can you see?
Yes. I
So
just checked
why
this, sir. Um,
uh,
yeah,
you might
it's
have
showing as
cross-verified.
succeed. Yeah.
It might be giving you error if you don't do it. If you don't put
Correct,
byte,
yes.
it
It's
gives
being
you
put.
error. And the moment you put byte, it it is removing the error. But because of casting, what is happening? The data is getting lost. Your above 3 bytes are gone. Only 1 byte is kept. So what is remaining in that 1 byte? All eight
Zero.
zeros. Therefore, the answer is zero over here.
Zero.
Correct? So if you don't want the data to be lost, then keep it in integer. Okay. So wisely you have to decide. Okay. Then some right shift examples we'll see, guys, quickly. Okay. Chalo, right shift examples. I is 12. Now, common sense. When you do right shift, it is half. So
Uh-huh.
2 when I'm doing, so is it going to half 2 times? So 12 half is 6 and 6 half is 3. Isn't it? And see, this is binary 12. I hope you agree. 1100 is binary 12. Now, when you shift it 2 times, 2 zeros will go out. This 1 1. And what is going to drop at MSB as this is 2 greater? What will
Zero.
remain in MSB? Huh.
Zero.
In this case, 0. Generalize what the rule is for 2 greater. For 2 greater, the generalized rule is what? The old sign bit. So if your old sign bit is 0, 0 is dropped. Old sign bit is 1, 1 is dropped. Yes or no? And when I use 3 greater when I use, that time, irrespective what the old sign bit is, always what will come here? 0 only. Getting? So as it is 2 greater, it does the shifting right side, but whatever the old sign bit, it is dropped here. Okay? Okay. So see here, when you shift it, what is remaining now? Tell me 1, 1. So this is 2 and 1. That is 3. Is it right or no? 1, 1 in
Yes.
binary is how much in decimal? 3.
Three.
Okay. Some more examples. Let's see. Now again, I'll not tell you that minus 42 is this thing. Okay. Means minus 42 is this. Is it 2's complement of plus 42?
Yes.
Whatever is your plus 42, it's 2's complement. Okay. And this is actually minus 42. But before doing shifting, is it promoted to integer? Yes, the rule is that only. No? We saw in the theory that A shifted n time. So before doing shifting, either left side or right side, A is promoted to integer or long. So here byte will be promoted to integer. Okay, so this is your minus 42, the red part which I've done. This is byte minus 42. But before doing shifting, it is supposed to be promoted. So promotion means the sign bit is pulled. Will it pull this sign bit till 31st bit? Yes, the sign bit is 1. So 1 only is pulled till 31st bit. Okay. Now, after that, you're shifting it 4 times. Will this whole nibble go out? This whole nibble come here, then this comes here, yeah, this is, and this come here. So what is getting dropped at the MSB? As it is 2 greater, as it is 2 greater, what is dropped? The old sign bit.
Sign bit.
So if your old sign bit is 1, 1 only is getting dropped. Okay. Now we have to convert this to decimal. Now let's check whether you have understood or no. Am I supposed to convert this directly to decimal or first I have to do 2's complement?
First, we have to do two's complement.
Why? Because in the sign bit
Sign
there
bit is
is
1.
1. When sign bit is 1, you should never convert it directly to decimal. It will be a very huge number. You have to first convert it to 2's complement. Okay. So can anyone tell me 2's complement from LSB till we don't get
1.
first one? Keep it as it is. This is your first one. Then after
1.
that complement, 0 becomes 1. And
2.
after that, everything is going to become 0, 0, 0. How much is this decimal?
3.
3. But I cannot write 3. I have to write minus 3 because I didn't get decimal directly from the original answer. Whatever your answer was, that you first converted to 2's complement and then you have taken the decimal of it. Always remember, when you take direct decimal, no need to give minus. 2's complement and then decimal, you have to give minus. And first of all, when we have to do 2's complement, when the sign bit is when the sign bit is 1.
1.
Whenever the sign bit is 1, then only we have to take 2's complement. Okay? Then one more example. Let's see. In this now I'm using 3 greater than, guys. The same example, only 3 greater. So as it is 3 greater, what will always come in the MSB?
0 as a sign bit.
Always 0. Because this is 0 fill right shift. And this is sign fill right shift. Use the technical words which I'm telling. It should get bombarded in your brain so that whenever you are facing interviews, each and everything is clear to you. 2 greater means it is sign fill right shift, and 3 greater means 0 fill right shift. And that's why see here, the same binary is there. This 4 goes out, then this 4 come here, this nibble come here. But what is coming in the MSB? 0.
0.
Now don't waste your time in converting to decimal. I've directly written the answer. But am I supposed to convert this to direct decimal?
Yes.
Because the sign bit is,
0.
as sign bit is 0, direct decimal, but it's going to be a very huge number because you have to add this 1, then this 4, 8, yes or no? 16, 32, 64, 128, 256, all that numbers you have to add and you will get this huge number. Getting? It's approximate to near to billion, 2 billion nearby. Okay? So hope the examples are clear to you. Right, guys? Quick confirmation, at least others tell yes or no.
Yes, sir. Understood.
Then what is your ultimate goal? Someone has answered. Tell me who answered. At least tell your name. I'm not going to fire you or something. Huh. I'm not going to
Yes,
come at your home and complain your parents or something. Huh. Tell me your good name.
sir, Rakhi Awasthi.
Rakhi. Getting what is your ultimate goal after doing this whole course?
Sir, I want to join a IT sector for my career
Very
growth.
good. Very good. Nothing wrong. Your aspirations are very high, but then for that you have to be prepared for that things. No? Like you
Yes,
want
sir.
to enter into a development field, lot of coding concepts should be very well perfect. You ask me anything, I'm clear with all the logics and I'm clear with each
Sure.
and every concept. Right or no? So
Yes, sir.
you're aiming very high, and I'll be always there till you don't get entry into some corporate. Once you get into, then if you forget me, no problem. Getting no issues. But till you don't get an entry, I'll be always there with you.
Sure, sir.
Next thing
Thank
we
you.
will learn. Okay, so we will move to next thing. The
Sir,
same
I
three
will not
operator.
forget you, sir. Remember, even means after getting job also, will especially I am telling myself, I will not forget you actually.
Okay, thank you very much.
Yeah,
Okay.
I'll keep in
At
touch
least,
every time actually. Okay.
okay, at least you should refer to my student. At least if I say like these are my student, if you have any requirement in your company, please recommend them. At least this much you will do for me.
Yes,
I'll be very much happy. Getting
yes, sir.
and my past students have been doing that only. From 1998, I'm teaching. There are so many. Some have gone till MD level. They've reached till MD in Senecron and all. One of my student, Amit Paste, has reached till MD. And he always say, if I'm having requirement, but send me good students. Don't. Otherwise, what will happen is if I send someone, he will feel ashamed that how can you say he's your student? Right? So that should not happen, right? So there are many such
Sure.
people in the industry. Those who refer me, they send the requirements if there are. I keep recommending to my students. The same three operators we have to learn, but in a compound assignment form. Like suppose you want to do A, you want to right shift it or left shift n time. And whatever answer you get, you want to store in A only. You want to shift A right side or left side. Okay, by 2 greater, 3 greater, whatever. And whatever answer you get, you want to store again in A. So the whole thing you can do it in a shorthand form by using a compound shift assignment. Means you can do like this: A right shift equal M. Okay, A right shift equal M. Means it is going to shift A right side n time, and whatever answer come, it will itself store it in A. Means the same thing in a shorthand form. I guess in the past we have discussed this for arithmetic operators. Yes or no? Arithmetic compound assignment. Then for bitwise also I took bitwise compound assignment. Same way shift compound assignment. Okay. Only the speciality of this shorthand is it will do implicit narrowing. Someone has kept mic still unmuted. Okay. Now what I want to tell you is that is shifting and assignment. Dual work is it. Here it does implicit casting. Okay, A is equal to whatever the data type is. A is either it is shifting left side or right side, doesn't matter. Okay, whatever answer you get. Now, obviously, that answer is going to be int or long, and that int or long will get casted to T, where T is the data type of A. That is the speciality, that it does implicit narrowing. Normally in Java, what doesn't happen? Implicit narrowing. Automatic widening is possible. Automatic narrowing is not possible, isn't it? Okay. So automatic narrowing you cannot do. Automatic widening you can do. But this is the special situation where automatic narrowing happens or possible. Okay? Check this. So X left shift equal A. So it is going to shift X A times, and whatever answer come, it is going to store in X only. X right shift A times and store the answer in X. And here also same thing, right shift, but this is zero fill right shift. This is sign fill. Only what is the speciality of this? After doing the shifting, the result is casted to X data type. See here, it is written that T is the data type of X. It will shift X left side or right side, sign fill or zero fill, and the result is casted to T, where T is the data type of X. Okay, hope it is clear. Example I'll take. So speciality is clear to you or no? The speciality of these three operators is it will do dual work. It will do shifting as well as assignment. And as it is doing two work at a time, that is shifting as well as assignment, implicitly it will cast the result to X data type, which when you do it in an expanded form, it doesn't do. Getting? Like if you're having byte A as 5, suppose guys. Okay. And there is another variable B and or A only if you take, not necessarily B. I'm saying like that A is equal to A right shift 2 times. Now, if I do like this, is it going to give an error? Just now we discussed. Just now, few minutes back, we have discussed. Check what is going on. Will this give error, guys? Yes or no? Again, you're there or no? Shamli is there again.
Yes, sir. I'm here.
So tell me, A right shift 2 times. What will be the result? I'm not asking you the exact answer. I'm saying the data type. This whole operation data type will be what?
0.
I'm not asking the answer. I'm saying the data type of that answer, result. A right shift 2 or A left shift 2. The result is of which data type?
It should be named.
Right or no? That's what my question is. My question is
Yeah.
very easy. It
Should
should
be
be
named.
integer. Why? Because it is byte. So byte is promoted to
Converted.
integer.
Yeah.
Okay. Byte promoted to integer. Either int or long. So here it is int. Now I am trying to store that answer in A, which is byte. Will it store it automatically?
No.
Again,
No.
we'll get an error, no?
Yeah. We'll get it.
Incompatible type, possible lossy
Yes.
conversion from int to byte.
Right.
Getting? But the same thing if I do it with a compound assignment like this. A equal,
Int.
okay, shift equal after, right? A shift equal 5. Sorry, 2, where A is already having 5. Now, will it give an error or will it internally cast it to A's type? Now, in this
Okay.
case, internally it is like this. No? A is equal to A right shift 2. Okay. But whatever the answer is it going to cast it to byte, guys?
Yes.
Yes.
Yes, sir.
Why? Because you have used it in a compound assignment. That is the speciality of compound assignment. It will shift a right side 2 times, no doubt. The answer will come integer. That int on its own, it will cast to byte and store it in a. Understanding or no? That is the speciality. Here we have mentioned on its own, it will cast it to X type. Okay? So when
Yes,
you
sir. But
write it in a, huh,
sorry, I have a question, sir. Sir, in this case, if anyone have written it as byte and it's a big number, then it will give answer as zero, right? Like it was done.
not always zero. It is
Depends on
depending
number.
on but you are right. What you want to say, you will not get what you are expecting.
Correct.
There will be loss.
Okay.
Getting? Because it will keep only that lower byte.
Exactly.
So
Yeah.
whatever is remaining in that lower byte, it's decimal because the upper 3 bytes are lost. So it will keep only that last 1 byte. So whatever is remaining in that last 1 byte, it's decimal. Getting?
Correct. Yeah.
So in the previous example, what happened is that last byte was remaining only zeros. Therefore, we got 0. Getting?
Correct. Correct.
Coming to this example, see here. Now integer I equal to minus 42. Now I'll not tell you this is the 2's complement of that plus 42. 42 is binary, and as it is negative, you have to take its 2's complement. This is that 2's complement. Now you're shifting it 4 times. Getting? So after shifting it 4 times, see here, this 4 goes out. This will come down. Okay, so this is the answer. But after whatever answer I get, am I supposed to convert to direct decimal or I have to find 2's complement of it again?
If it is a sign bit one, then we have to give two
So
complement.
you tell me now what you see
Yeah,
in the
yeah.
sign
It's
bit.
two's
If it is
complement.
1, you have to take 2's complement. So this 1 will remain as it is
Then
from
one,
LSB.
zero,
Then that 0 becomes 1
one.
and all other are 0, 0, 0. You know, all others are 0, 0, 0, 0, 0. What is the decimal of this two ones? This is 2 and this is 1. That is 3.
Three minus
Yes,
three.
sir.
But we have to put minus. Why I have put minus? I hope you got it.
Yes.
Why I have put minus? It is clear to you,
Yes.
is it? Because I have not got the decimal of this directly. When you get directly decimal, it is positive. And when you are getting decimal from 2's complement, it is sure negative. So you have to put minus. Okay. Now coming to this part, you can check A left shift 5 times. And I'm using this compound form. And as I'm using compound form, why my answer is coming minus 128? Your doubt will be solved now, Shamali.
Yes. Yes.
Getting? So see here. Now don't
Yes.
consider this part for time being. For time being, don't consider this part. Only this part will consider. Okay. So what is A12? Is this 12 right in binary? 1100.
Yes. Eight and four.
Okay. 8 and 4, 12. You're right. Now you're shifting it 5 times. Towards which side? Left side. So 5 zeros are coming inside. See, 0, 0, 0, 0, 0. 5 zeros. And after that, everything. Okay?
Yes.
Right? And remember, now you will say A is byte, then why you're showing 31. Why again I have to tell you, before doing the operation, it is promoted to minimum int or minimum long. In Java, never operations are happening directly on byte or char or short. Char will come to integer. Short will come to integer. Byte will also come to integer. Minimum integer. Okay. So this is your 12. 12 shifted 5 times. Okay. And then what happens is, as you have done it as a compound assignment. As it is a compound assignment, will it on its own cast the answer to A's data type? It will not give any error. On its own only, internally only, it will cast it to A's data type. A's data type is byte, therefore it is casting to byte. So above this, everything is lost. Only what is remaining? 1, 0, 0, 0, and this 4 zeros. Now tell me, am I supposed to take direct decimal or again 2's complement?
Who's complement?
Why? Sign bit
Because
is
it is 1.
1. But what will be the 2's complement of this? Same, no?
Same. Yeah.
As it is byte, 8 bit. So from LSB till you don't get first one, keep it as it is.
Correct.
Okay, but after that we don't have only. So 2's complement is same. Okay, now 1 is at which place? 7th place. 0, 1, 2, 3,
Yes.
4, 5, 6, 7. So 2 raised to 7 is 128.
128.
But we cannot write 128. We have to write minus because we didn't get direct decimal. 2's complement and then decimal. This example is like that its 2's complement is also same. This is your answer after casting. After casting it to byte, this is the answer. But whatever answer you got, its sign bit is 1. Therefore, the number is negative. You have to take 2's complement. But when I take 2's complement, the same thing I get. Right? And then its decimal is 128. I have to put minus. Therefore, here you get minus 128. You understanding? Suppose by some means after casting, this casting means this above 3 are gone. Only 1 byte is remaining. But here 1 is not there. Instead, that 1 is somewhere here. Then will you take 2's complement or you will convert direct to decimal?
Direct to decimal.
Because in the sign bit is 0, so direct
Yes.
decimal. So this is 6th bit, 64. So you will take 64. But why in our case we got minus 128? I hope you got it. After casting, you got this. Okay. But whatever is remaining, in that also sign bit is 1. Therefore, sure the number is negative. Okay. But whatever remaining, its 2's complement is same again, guys. And then the decimal is 128 with sign minus. Okay. Okay. So this part is also clear to you. Then few operators are remaining and we just keep checking recording is going on or no. Coming to the next operator quickly. So I hope everything is fine related to shift operators, right?
Yes, sir.
Yes, sir.
So in the group, whenever I give some Gemini test question, try to solve it. It just brush ups your concepts. Whatever is taught in the class, it just gets recalled. Huh? Yes, he taught these
Yes, sir.
operators, right? So try to appear for those. Moving to the next operator. This is the only operator which is ternary operator in Java. Okay, the only ternary operator. Otherwise, nearly major are binary and few are unary. Okay, this is the only ternary. You can say this is a shortcut form of if else. When you want to perform very simple expression in if part and a simple expression in else part. You don't want to perform a block, an entire block in if and an entire block in else. Then don't use this. A simple expression I want to run in a if part and an expression in a else part. Then go for this. Okay, so this is having three parts. First part is the condition strictly. And when we say it is a condition means it is a Boolean expression. It is a Boolean expression. And I hope you know it. Boolean expression means it is evaluated to true or false strictly. You cannot use any other data type, which is legal in some languages. Actually, Python doesn't have only ternary. Like in JavaScript or C, there we have ternary. And there is no such rule that the condition is to be binary, Boolean only. There, if you use a string or an integer, it will internally convert it to Boolean. Correct? But here it's not like that. So condition, then you have to put question mark, then expression 1, okay, colon, and expression 2. And if you remember, when I took topic operators, when I took the heading operator, I started with that topic. That time I have told you in Java, before doing any operation, the operands are fully evaluated, except only two situations I have told in Java where fully evaluation is not done. One, the short circuit logical operators, conditional logical operator, that is to and to or. Are they fully evaluated, or only the first operand is evaluated? And on the result of first operand, the second is to be evaluated or not is decided. Yes or no? Tell me. Does it evaluate A and B both, or it only evaluates the A part? And on the result of A part, it decides whether to go to B or not. So see, in ANDing, if the first part comes false, complete false, it will not waste time coming to B. And same way in ORing, if the first come true, if A come true, directly true, it will not check B. So no fully evaluation. And this is the second one. So remember in Java, these are the only two operators where what is not done, fully evaluation. But if you take any other operator like plus, so always remember here when you're doing plus, A is evaluated, B is evaluated, and then the addition takes place. Fully evaluation. You should remember that points. Okay. So here what is evaluated first? The condition. If the answer is true, only expression 1 is evaluated, huh, guys. And if the condition is false, expression 2 is evaluated. It will never evaluate both the expressions. Understanding? It will not evaluate both the expressions. Only one from that, but depending on the condition. So if your condition is true, it will evaluate first part. And if the condition is false, it will evaluate the second part. I hope that part is clear to you. Okay. So remember, if I write A greater than B, true, I'm writing plus plus A. Otherwise, I'm writing plus plus B. So what do you think, guys? After the operation is done, are both incremented? Is A also incremented, B, or any one only from that?
Only one.
It depends on the condition.
Condition.
So if the condition is true, if the condition is true, A will be incremented, otherwise B, but not both. And this proves it is not going to increment both. This proves that here how the evaluation is not happening fully. It doesn't do full evaluation. Means this is evaluated, this is evaluated, this is evaluated. Not like that. It will not evaluate all three. It will only evaluate the condition. True, then this or this. Getting? And here you can have nested concept also. Like I'm writing A question mark B. Suppose I've written question mark C. Okay. Question mark D. Then colon E. Colon F. Okay. Colon H. If I write like this, what happens is it is from the right side matching. Means if A is true, it will take this whole thing, and false, it will take H. Means for A, the false is H. Okay, guys? And the true is the middle part. Now again, for B, the false part is F. Okay? And the true part is this whole thing. And then For C, the false part is E and the true part is D. So how the matching is, I hope you got it. From right side. From right side, it will match with the else part. So A's else is H and the true part is, if part is this whole. B's else is F and the true part is this whole. And C's else is E and true part is D. So you should remember that. In that way, the matching is done. Okay. So check the syntax: condition, question mark, expression 1, expression 2. Okay. Three parts are there. I told you. If the Boolean expression condition, this has to be a Boolean expression. If it is true, then it will evaluate expression 1. Otherwise, it will evaluate expression 2. Okay? Then the value of the expression evaluated is returned because it's an operator. Every operator has to return a result. There is no operator which doesn't return result. Okay, so here the result is either the answer of expression 1 or expression 2. The value of expression evaluated is returned by conditional expression. Example you can take. Here, does it check whether leap year is true or false? So in leap year, now leap year is a Boolean variable, therefore allowed. Okay, it's a Boolean data type. Now, if it is true, then 29. That 29 will get stored here. And if it is false, then 28 will get stored here. So as leap year is false, it goes to else part and 28 is stored. Okay. And this conditional operator is very much like if else. The conditional operator is the expression equivalent of if else. And if you have nested, if this expression 1 is again a conditional, expression 2 again is a conditional. So if it is in a nested way, then the matching is from the right side. It is like bracketing rule. Yes or no? Whenever we put any brackets, okay, so you know it. Who is matching? For this first bracket, the last one is matching. For the second last is matching. Isn't it or no? This is a common technical round question. If you go to LitCode platform, there also this is a very common question that write a program to check whether the expression is a balanced parenthesis or no. And they will ask you which data structure you'll use. So you'll be using stack data structure. The best data structure is stack. Okay. See here. So the conditional expression can be nested. And if they are nested, then the matching is right to left. See, example I'm giving. So false, A's false is G. Okay. A's false is G and true is this whole thing. Then B's false is F and true is this thing. C's false is E and true is D. Okay. See, it evaluates in that way. Getting? Only here by mistake I wrote question colon. It is question mark. It is question mark. Please. Okay, I'll make changes over there. Like this. It's like this. Okay. So I hope that part is clear. Now these three operators are remaining. I have to teach you these operators, but explanation will take time. So I'll keep it aside. Meantime, what we'll do, we'll see some examples. Let's see. Okay. This example, you can tell me the outcome of that example. In the next session, we'll complete the three miscellaneous. Then the operator topic is over. Then we will start writing some programs based on operators. So I'll tell you how to accept value from the keyboard. Okay. Then what is system.out.print? All that explanations I'll give you. Okay. in this case. Now tell me, is this test a static method? Test is a static function. Void means it's not going to return anything. Test is a static method, means to call it, you don't have to create object. Yesterday I have told you, to invoke it, there is no need to create object of this class, my class, because it's an instance method. Okay, as it's a, sorry, because it's a static method, very sorry. If it's an instance method, then you have to create an object and then with a dot operator, you have to call object dot test. As it is static, directly class name, my class dot test. But when I'm calling them, I'm not even writing that class name because I'm calling it the same class. When you're calling it in the same class, no need to even write class name. And what you are passing, one integer and one string. Inside what it is doing, it is shifting that integer right side. Getting? Again, here one mistake I've done. Very sorry. There's one small mistake. Why it happens, you should know it. It is the pros and cons we say, no? It is cons of using AI tool. Getting? So when I have some good certification books. So what I do, I just crop it from that book and give to AI tool. And I tell to the AI tool, please extract the text from it and give me. So sometimes there are errors remaining. While extracting the text, 100% the exact text cannot come. Somewhere, some characters are lost or some characters which we expect, it may give you something different. Correct? So there has to be some error in the AI tools. Like it cannot be 100% like human brains. Okay. Okay. So that was my mistake. I did it. Yeah. 3 greater and 2 greater. I'm shifting I one time by 2 greater and I'm shifting I one time by 3 greater. I hope you know it. When this both shift answer will be same. Today only I asked you. I asked you also that question. That when we get by 3 greater and 2 greater, the answer is same. When the number is, don't remember. Today only I told you guys, by 2 greater and 3 greater, you know it, by 3 greater, what is going to come in MSB? 0. And by 2 greater, the old sign bit. So suppose if your value is positive, if it is positive, then what is the sign bit? 0. So if you shift it by 2 greater or 3 greater, the answer is going to be same only, na guys? Right or no? But if your value is negative, then by 2 greater and 3 greater, the answer will be different. I hope you know that thing. Okay. So tell me for the first time, what will come in I? 1 is shifted 32 times. Will it shift it 30 times or will it do masking of it? Will this 32 be masked with 31? I told you now how the shift distance are calculated. Okay. So this is 7th bit, 6th bit, 5th bit, 4th bit, right? And 0, 0, 0, 0. Is this 32? Yes. Now this is going to get masked with what? 1F. 1F means 1 and F means 4, 1. Tell me, after masking, what will be the result? Orally also anyone can tell. Masking means ANDing. So when I AND it, what will be the result? This is 32 and this is 31. I told you also, today also, yesterday also, when this shift distance is 31 and less than 31, no need to mask. It is going to remain same. But the
Same like
moment it goes more than 31, your answer is going to change. Okay, so what will be the answer after ending? Zeros, no, all. Is it going to be zeros, guys, after ending?
Yes, yes.
Zero, 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 zero. So in short, is it going to shift 1 32 times or 0 times? 1 shifted how many times? Means what is the actual shift distance?
Zero.
Ah, you're right. It is 0. The shift distance is not 32. It is not going to shift 1 32 times. It is going to shift 1 how many times? 0 time. Getting confidently you should answer. Why? Because you got the shift distance by masking 32 with 1f. 1f means 31. 1f is 31. After masking, you got 0. So it is going to shift 0 time. So 0 time shift means as it is, right or no? So what will remain after shifting? 1 only. So that 1 will come in I. Now tell me that 1 you're shifting right side by 2 greater and 3 greater. Are the answers going to be different or same?
It's going to be same.
It is going to be same because the sign bit is 0.
Zero.
So see here, na, when you shift this one out right side, what is containing I? What is I containing? Wrong English. So I is containing 1. So I'm shifting 1 time. So this will go out. What will be the answer by 3 greater and 2 greater? Same answer. So as both are same, is it not equal? No, it is equal. Therefore, will it print EXP? No. So no printing will be done. It will not print this. Okay? But tell me if I am doing one shifting 31 times. So what will be the shift distance for 31? 31 only, no?
31.
31 only. So your 1 will be shifted how many times to the left side?
One time.
How one time? What is the shift distance?
31.
31.
31.
31 masked with 31. Masked means ANDed. 31 ANDed with 31. 31 only.
31.
Okay. So 1 is shifted how many times? 31 times. This 1 will be shifted 31 times. So is this 1 coming here at the 31th bit?
Yes.
Okay. And after this thing comes in I. This answer, after shifting 131 times, this answer will come in I. And that again you are shifting right side 1 time. Again, right side. So tell me, by 2 greater and 3 greater, are the answers going to differ or they are going to remain same? Remember, this was 1. 1 shifted right, left side 31 times. You got this. This 1, 31 times shifted here. You got this. This has come in I. And again that you are shifting 1 time right side. Okay, so I don't want answer. I just want whether they both are different or same. Tell me, guys, if you shift it 1 time, this 0 goes, this 0, 0, 0, 0. Then this 1 will come here.
Here.
And what will come here?
This 3 time it will be 0.
Correct. 3 for 3 time it will be 0. And for 2 time that 1 only,
As it is.
as it is. So means are they both coming same or different?
They are different.
They are different. Therefore, it will print EXP.
Yes.
This value is printed. Okay? I hope you remember the second value is print because that answer has come different. Okay. Now tell me for the third case. When you're shifting 130 times, what will be the shift distance? 30 only. You can check it. When you mask 30 with 31, you'll get 30 because it is less than 32. Okay. So 1 is shifted 30 times. So you'll get something like this 0, 1, 0, 0, and all 0, 0, 0 in the bottom. Your 1 was here, and you have shifted it how many times? 30 times. So
30
it will come
times.
to the, so it will come here, not last, 30 times. Now this value is copied in I. 1 shifted 30 times, and whatever answer come is coming in I. And again that I is shifted right
One time.
side 1 time using 2 greater, 3 greater. Will the answers be same or different?
Different.
Think again. Again you think.
Sir, I's number will be shifted 38 time, right? Again, one time again, right? To the right.
1 time. This
So
is
this is the
shifted.
right correct answer for now. 0100, then the last bit it will be 00.
No, this thing has come in I.
I, yeah,
And then again you're shifting it by
one
2
time.
greater or 2 greater or 3 greater. So I am asking by 2 greater or 3 greater. You shift it. This 1 will come here. This 0 will come here. Right or no? This is shifted.
Yeah,
But by 2 greater or 3 greater, are the answers different or same?
they will be different.
Think again, guys. As your sign bit is what, guys?
Here it's 0. For 3 time it
So
will be,
same.
yeah, same only.
When you do 3 times, the old always 0 come.
Yes,
When you do it by 3 times, always 0 come. And by 2 greater, the old sign bit. But old sign bit is also 0 only now.
0, yeah.
So why you're forgetting the rule? You're forgetting the rule that when the sign bit is 0, okay, then you do it by 3 or 2. The answer is going to be same or different. You tell me if this is my number 0, 1, 1, 0, 0, 0, 1, 1. If I'm telling shifted by 2 greater, what does 2 greater do? It does shifting. Okay. And what it keeps in the MSB?
1. Sorry, as it is. Whatever the
Uh,
last sign will be, it will keep it as it is.
you got it. Okay. This is because of 2 greater.
Correct.
And what does 3 greater do? It will shift it. This
It will
1
shift
will
it,
go
yeah.
out. Okay, it will shift it. But what it will put at MSB?
It will put 0.
Huh.
So it will be same.
So,
Yeah.
so that's what. So conclude. You have to conclude. You have to find out the conclusion.
Yes, yes.
You have to
Because,
make a conclusion rule.
yeah, I was
What is the
confused with first number. I was taking second number for shifting. That's why. Okay, now I got it.
this is just a string send here
Yes,
for
yes.
printing. Okay. So I hope you got it. So when 1 is shifted 30 times, right, left side, you get this thing that 1 was here and 30 times shifted that 1 reached here. Okay. So this whole answer you have passed to I. And again you are shifting it right side by 2 greater or 3 greater. So what the answer is after shifting, don't worry. You just have to check whether they are not equal. But no, they will be equal. Why? Because the sign bit is, when the sign bit is, expecting answer. When the sign bit is 0, guys, whenever the sign bit is 0, you shift it by 2 greater or you shift it by 3 greater. You shift it by 2 greater or you shift it by 3 greater. The answer is going to be
Same. Okay.
same. But if your old sign bit is
1. Then it will
1,
differ.
then it will differ. Okay, so I got it. I hope you got
Now
it.
I got it. Now
So
I got
now it is not going to print anything. Printing was done only for this
it.
case.
30.
Now coming to this case, the fourth one, directly 1 has come here. Again, no need to check also. 1 has come. So 1 shifted right side by 2 or 3. Will the answers be different or same? By two greatest shift or three greatest shift? Will the answers be same or different? It will be same because
Same.
the number is positive. As the number is positive,
The first time it will be
the sign bit will be zero only. No? This is your one. Okay. And what will be the sign bit? Zero.
0.
Now, if you are shifting it right side by two greater or three greater, what will be the new sign bit? Zero only. The answer is same. So no printing in this case also. Then in this case, as it is zero, they will not come
Same,
same.
it will not come.
No printing. Getting same. But about minus one,
It will
it's so easy to remember. Minus one means it is negative. And when it is negative, its sign bit is sure going to contain what?
1.
Right? Whatever the bits are down, but
Yes,
what is the sign bit? One.
it will be 1.
So if you shift it by two greater, this one will come here and the old one is dropped.
As
And if you do it by three, that one will come here, but here zero will come. So tell me, will the answers be different or same?
different.
Different. Therefore, this minus one string which has come, a double quote,
Yeah.
is printed. So printing is done only in this two situation to select the two correct answer. Who is printed? One,
31 1 and 1 minus
this
1.
one, and this minus one. I hope you got it.
Yes,
Please make a rule. You have to make a rule. And no need to waste time also in checking that shifting and all of this thing. You should remember when the number is positive, if the number is positive, you do it by two greater or three greater. The shifted result is same. But if the number is negative, the sign bit is one. Therefore, if you shift it by two, the new sign bit is 1. And by 3, the new sign bit is 0. So obviously, both the numbers are going to be different. Okay. Okay. One more question you answer. Which of the following are not operators in Java?
Option D, sir.
Option
D.
B, you are telling, no? B for Bhopal. B you are telling or D you are telling?
D, sir. Fourth one.
it's F,
Fourth.
sir.
Again,
It's F.
these guys. D is there, arithmetic compound. You might be absent and you have not watched the videos. This is arithmetic compound. You can do A modulo equal B is legal. What it is
Yes,
doing,
yes, sir.
it is actually doing A mod B, and whatever answer come, it is storing in A. It is compound arithmetic assignment. Okay, so this is legal. Modulo is legal, and is
F,
legal. Huh. D also I told you legal. F someone is telling, but it
F
is
and
less than equal operator. No, this doesn't work. A less than equal to B.
yeah, it will work.
It's legal, sir.
Huh? It's legal. Three greater than sign. Just now we discussed. Just now we were talking about that only.
B, sir.
Okay,
B is not there.
we don't have three less than.
Yeah,
Three greater than we
we
have.
have
Three
greater
less
than.
than we have. And this short circuit logical operators which are there, conditional logical, you cannot use it in assignment form, which I've told you also while explaining when I took the topic conditional logical operator. I have told also they are short circuit evaluated. Only A is evaluated first. And if the answer is true, then only it will come to B. If it is false, directly false. So in this case, you cannot do such compound assignment. It is not allowed. Okay? So basic things are there. No? My intention is not only again to get entry into corporate. My intention is that you people clear your certifications also. It will be an asset. No? If you have certification, then your actual interview process becomes easy because many of the corporates see that you're already Sun certified. So automatic your interview process becomes lenient. They don't go into much deep, getting because they know that you have already prepared for the certification exams. Huh. But our certificate, Sun certification exams are not like NIT exams. Huh? They are not the NIT exam which is going on. There is a paper leakage, and then you get a paper by paying money, and then you crack that exam, and then you announce yourself, I'm Sun certified. It's not like that. You have to seriously prepare for that, and you have to appear for their exam. Okay, coming back. So quickly this question, and then we will halt for today. We'll take a pause for today. Given a value, given a variable x of type integer, which are correct ways of doubling the value of x? Don't bother about loss or anything. Means if there is implicit casting going to happen, don't worry. They are saying bearing any wrapping of out of range intermediate value. Means implicitly, if the casting is going to happen, and then in the casting some losses, don't bother about it. Okay, so don't worry. So which one from this is going to double your value of x? If I multiply anything, and x is integer, so integer into 2 is int stored in int, no problem. Tell me, if I multiply anything by 2, is it going to double? This is compounder, remember.
Yes, sir. It will double.
It will double. It is same as x is equal to x into 2. And you know that when we do compound operation, implicit casting is happening. No? Here also, it is a compound arithmetic. If we add anything to itself, is it going to double? X is equal to x plus x. X plus x is double only. No? And yesterday also I told you, right shift, half the value. Left shift, double the value. Whenever you do left shift, does it double the value?
Yes.
X is equal to x, left shift, one time. So whatever is the value of x, it is shifted left side one time. So it is going to double only.
Double it. Yeah.
So what do you think? Which one is so? Which one is not correct? Many may think what is wrong with the first one. It is also shifting left side one time, but it is not doing any side effect, guys. It is just the expression. Means the answer you will get, which is x double, but it is not doing side effects. Side effect means is x getting changed? This is just the expression. You understanding, now? When I write x left shift 1. So whatever the value of x is, it will shift it one time and you get an answer. It gives you the result. X is as it is. In the memory, whatever value of x is, it is as it is. It is not changed. But if you assign it, then is the value of x going to change in the memory? Whatever result you get, it will store there. So what happens is these four are doing side effects, but this is not doing side effect. Side effects means what you are understanding, na, guys?
It's storing the value of x.
Means it is making change in the memory. Whenever there is a change happening in the memory, we say it is side effect. Here in all four, there is a side effect. Value of x is changing, value of x is changing, x is changing, x is changing. Here, this is just an expression. This is just an expression. It is just evaluated and you get an answer. X doesn't modify in the memory. Okay. Therefore, this is not valid. Okay, so for today, we will take a pause over here only. Tomorrow, that remaining three, tomorrow means next Monday, we will take the remaining three operators, miscellaneous operators are remaining, that I'll tell you. And then we will dive into another topic. Operators are complete. Then a new topic.
So,
Okay.